Hello everyone, welcome back to my YouTube channel. This is Filipino explaining. So let's look at determinants and diagonalization. And under this determinants and diagonalization, we shall be dealing with uh, uh, co-fact expansion theorem. Determinants and diagonalization. So let's look at determinants and diagonalization. And under determinants and diagonalization, let's look at this, the co-fact expansion. The co-fact expansion. Without wasting time, let's consider this matrix A given as A, B, C, D. This is a matrix. So how can we get or determine the determinant of this matrix? Remember, this matrix is a 2 by 2 matrix. This matrix is a 2 by 2 matrix. Two rows, as you can see, have two rows, 1, 2, and we have two columns, 1, 2. So it's a 2 by 2 matrix. So how can we determine the determinant of this? The det of A, or the determinant of A, is given by A, B, C, D this way. So we take the product of this diagonal. Remember, we are dealing with the determinants and diagonalization. So this one, are you seeing? These are diagonal. So you get the product of the elements in this diagonal. That is A and D. So the product is AD. Then we subtract the product of the elements on the other diagonal. Remember, these diagonal are the one that I have circled with a red pen. The red ink is the main diagonal, and this is the other diagonal. So we subtract the product of the elements in the other diagonal from the product of the elements in the main diagonal. So the elements in the other diagonal is A and B. So the product is BC or CB. BC. So the determinant of A is this one, AD minus BC. Okay. Theorem. And this theorem is the co-fact theorem. Co-fact expansion theorem. Remember, we are not just looking at the determinant of matrices. There's a video that I did created on determinants of 2 by 2 matrix, 3 by 3 matrix. If you have watched, you have not watched them, kindly go and watch them. I already uploaded them. They are on YouTube or in my channel. On my channel. So let's look at this theorem, co-fact expansion theorem. That this theorem states that, or we can describe it this way, that the determinant of an n by n matrix A can be computed by using the co-fact expansion. Along any row or column of A, that is that A, or determinant of A, can be computed by multiplying each entry of the row or column by the corresponding cofact and adding the results. So let's look at one example here. You have been asked to compute the determinant of A, and A is given by 3, 4, 5, 1, 7, 2, 9, 8, negative 6. This is our matrix. Solution is a 3 by 3 matrix. You can see 3 rows, 1, 2, 3, and 3 columns. So it's 3 by 3 matrix. So solution, the cofactor expansion along the row, in fact is the first row, along the first row is as follows. That A is equals to 3C11. You can see this C is for cofactor. A 1 1, first row, first column. You can see 3 is in first row, first column, 1 1. We add 4 C 1 2. This is the first row, second column. This first column, this second column. Then of A, we add 5. First row, third column, A of A. So this is what happens. We take this 3, we multiply by this. Are you getting? 3 we multiply by this. Note this is not included. Anything under 3 is not included in that multiplication where 3 is used as a multiplying factor. Are you there? So this is 3. This 3, we take this 3, we multiply by this one. Are you seeing? 7, 2, 6, negative, this is 8, sorry. It is 8 here. Then negative 6. You can see it's like we have just converted this one into 2 by 2 matrix. Like this one here. So the first one, it will be positive. Here will be positive. But the second one, we alternate, we alternate the signs. Which as this is positive, so this will be negative. This is what I mean. The first one will be positive, the second will be negative. 4. So 4 we multiply by this one, this and this, this and this. Anything under 4, we leave them out. So 1, 9, 2, negative 6. Then we add. I have said positive. Remember the scatter sign rule. Render the scatter sign rule. Positive, negative, positive, negative, positive as it goes. So here is positive, is negative, here is positive again. So it is 5, we multiply by what? The determinant of this now. This. Anything below under 5, we leave them out. So you have 1, 9, 7, 8. Are we there? So it's easier to determine the determinant of a 2 by 2 matrix. You just take the product of the elements in main diagonal. We subtract the product of elements in the other diagonal, this diagonal. So we take this 6, we multiply by 7. That gives us negative 42. Are we there? Negative 6 times 7, negative 42. We subtract 8 times 2, that is 16. But the whole of this will multiply by positive 3. We minus 4. This 1 times negative 6 is negative 6. We subtract 9 times 2, that is 18. Plus, this is 5 here. 8 times 1, that is 9. 9 times 7, that gives us 63, sorry. That gives us 63. So this will give us positive 3, negative 42 minus 16. That gives us negative 58 minus 4, negative 6 minus 18, that gives us negative 24. Then we add, this is 5, 9 minus 63, that gives us negative oh, there's a mistake here. Oh, this is 8. This is 8. I have been wondering where this 9 is coming from. So this 9 times 8 times 1, that is 8. Are we there? So it's okay. So 8 minus 63 gives us 55 negative. So if you work out this one, this times 3 times negative 58, you subtract 4 times negative 24, then you add 5 times negative 55, it will give you negative 353. Are we there? So you have to remember this. I have mentioned it, but I shall repeat it and say that the signs alternate along the row indeed. Along any row or column. Now we compute the determinant or the determinant of A or det A by expanding along the first column. I'll just write a note here and say we can as well compute the determinant of A by expanding along the first column. Along the first column. Instead of using the other process that I have used here to get the determinant of A as negative 353. We can use another method of expanding along the first column. Let's see. So we say the det A is equals to 3C11 of A. We add C21 of A, then plus 9C31 of A. From the equation, 3 is in position first row, first column here. As you can see, 1 in the second row, first column, as you can see, so it's 2, 1. Then 9 here is third row, first column, 3, 1, as you can see. Say that's 3, 7, 2, 8, negative 6, minus 4, 5, 8, negative 6, plus 9, 4, 5, 7, 2. Are we there? Then this will give us 3. We shall just take find the determinants of these 2 by 2 matrices we are seeing in this, and then you multiply by the factors outside. So the first one will be 3 times. Of course, we shall get negative 58 here, minus negative 64 times 1. Are we there? Plus, this is 9, here is 1, 4. This one will give us, this time this is 8, we minus 35. That is negative 27. And of course, it will reach us, will bring us here, negative 353. 353. The same thing as this one. Okay, so you can say that determinant can be computed by expanding any other row or column. So you have two methods that you can use to determine the determinant, or to find the determinant of a matrix by using this theorem called fact expansion theorem. The first method that you can use, the one that is commonly used, and the second method of expanding a row or a column. You get this one. Thank you so much for watching. Till next time, bye bye.